All right, so this is the area problem. So you're familiar with this type of problem from the earlier sections. So to attack this problem, we first need to construct the region, okay? Surrounded by these four curves, y equals x cubed ln x, y equals 0, which is x-axis, x equals 1 is a vertical line, and x equals 3 is a vertical line. So why don't you go ahead and use your TI-84 or 83 to graph x cubed ln x, let's say from 0 to 4. So you can take your x min to be 0, x max to be 4, and let's see what it looks like. And I'm going to do it right here. So I have already something graphed here. You can pause the video and you can check what I got here with yours. Okay, you can compare that. And the blue curve is in fact what you should see in your calculator. That's x cubed ln x. And I have the vertical line here, x equals 1 and x equals 3. The vertical line, x equals 3, intersects the blue curve at 3 cubed ln 3. That's 27 ln 3. That's the value that the blue curve attains at x equals 3. I just wanted to put that as a horizontal line to show you that intersection here. So this area mentioned in the problem is the green shaded region, okay? So I'm going to find the area of the shaded region, all right? Green region. So we know how to write down the formula for the area. So let's go ahead and write it down. All right, the area is going to be the integral of x cubed ln x, and then the limits for the integral is going to be 1 and 3. So let's go ahead and write down area is equal to integral from 1 to 3, x cubed ln x dx. Okay? So here in this problem, writing the area formula is not a big deal, but how to evaluate this is a deal, okay? So we have polynomial against logarithmic. So I think we have to go back to our L.I.A.T.E and remember who to call u if you have a logarithmic against polynomial. Well, polynomials are algebraic functions, so I'm going to call the logarithmic one to be u to start with. But first, as always, we should take care of the indefinite integral, x cubed ln x dx, to start with. And as I said, u is going to be ln x, and dv is going to be x cubed dx. Okay? So du is dx over x, and v equals the antiderivative of x cubed, which is x to the fourth divided by 4. Okay, so then this indefinite integral is going to be x to the fourth divided by 4 times ln x minus v du. Okay, 1/4, and du is let's see, 1/4 x to the fourth. We have divided by x, so x cubed. All right, we have one more integration to take care of. Okay. So x to the fourth over 4 ln x. X cubed is integrated as x to the fourth divided by 4. Okay, you have another 1/4 outside the integral. So that's x to the fourth divided by 16 plus c. Okay, this is what the antiderivative of x cubed ln x is. So I'm going to go ahead and use the fundamental theorem of calculus. So essentially, I'm going to write here x to the fourth divided by 4 ln x minus x to the fourth divided by 16, and I do not need plus c anymore, right? Because we're doing fundamental theorem of calculus. So 1 and 3. Let me just clean this part real quick because we don't need the UV scratch work anymore, right? So here we go. I'm going to plug in 3 for x first. 3 to the fourth, 81, divided by 4, ln 3, minus 3 to the fourth divided by 16. That's 81 divided by 16. Minus 1 to the fourth, so 1/4 ln1 minus 1 over 16. Okay. Again, at this point, we're keeping everything exact. Okay. So ln1 is 0, by the way. We can immediately use that. So ln1 is already 0. So what are we left with? Well, 81 over 4 ln3 minus 81 over 16 plus minus let's see, did I miss? I think I missed. Let's see, the famous divided by 16, right? So I'm just checking if I missed anything. Oh yeah, this should be yeah, 1 over 16. That's correct. Yeah, I'm good. 1 over 16. There we go. All right, this is negative 81 plus 1 divided by 16, so that's negative 80 divided by 16, and that is 5. All right, so far, again, we haven't used any calculator, but if you want to get an approximate value, go ahead and punch in this expression here and get the approximate value to be 17,247. So that's the approximate value of the area that we have here. Okay, so you can go back and say like this area is approximately equal to 17.247. Okay, I think that takes care of everything. So that makes it the end of the video. Thanks for watching. If you have any questions or comments or suggestions, please send those to my way. I'll see you in another video. Bye.